So in the final part of the video, I just want to emphasize briefly how useful the completed square form of a function is now that we know how to do it. And I've got a function here, f of x, and I've written it in two forms on the right. I have the completed square form on the top, and at the bottom I just have the standard form, the ax squared plus bx plus c form. And I've talked to you before about the turning point of a quadratic and its coordinates. And if we look at this graph here, we can see that it has a maximum point at -4 and 8, -4, 8. And we can read this directly from the completed square form. Inside the bracket here, we see a +4, which means that the graph is located 4 units to the left of the origin. And the 8 at the end means that its turning point is located 8 units above the origin. And the minus at the front, again, means that it's an N-shaped graph. Okay, but on the other hand, the standard format of the function doesn't really tell us anything unless we go and sub in points and plot them. So that's the main reason why the completed square form is really useful. But there's another reason, and I'm going to show you that now. In a previous video, I talked about finding the roots of a quadratic function, and I said that all the roots are just the x coordinates of where the graph crosses the x-axis. And we talked about two different methods we can use to find these roots. One was by factorizing, and the other was by using the quadratic or -b formula. Turns out there's also a third method, and it's a really useful method if we already have our function in completed square form. First though, I'm going to bring up the function in its standard form, so -x squared minus 8x minus 8. I can't see any nice factors there, which means I would use the quadratic formula if I wanted to use one of my old methods. So let's do that. How do we begin? We first set our function equal to 0, because where the function is 0, or y is 0, that is along the x-axis where the roots are located. Then we identify our a, b, and c from the formula. A is always the coefficient of x squared. Here it's -1. B is the coefficient of x, which is -8, and c is the constant, which is -8. Okay, the -b formula itself. So this is in the log tables. It's x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So let's fill that in for our coefficients. -8 is b, so that means -b is 8. So we have 8 plus or minus the square root of -8 squared minus 4 by -1 by -8 all over 2 by -1. If I sub that into my calculator for both the plus and the minus, I'll get the following two answers. X is equal to -4 plus 2 root 2, and x is equal to -4 minus 2 root 2. Okay, so that's how we use our usual method. But let's look at the other method we can use if we have the function in perfect or completed square form, I mean. Okay, so we start the same as usual by setting our function equal to 0. Now we can solve it as we would a regular equation. What we do is we first bring the 8 to the other side of the equal sign, so it becomes a -8. We can now multiply both sides of the equations by -1, so it's positive on both sides. To get rid of this square here at the top, we would take the square root of both sides. What does that leave us with? X plus 4 on the left is equal to plus or minus the square root of 8. The reason we have that plus or minus there is because when you square a negative or positive number, you will always get a positive answer. So if we had minus root 8 squared, we would still get plus 8. So we need to take account of those two possible solutions. Finally, then our last step is just to bring the 4 to the other side to solve for x. So x is equal to minus 4 plus or minus the square root of 8. And root 8 simplifies to 2 root 2. So minus 4 plus or minus 2 root 2. And that's the same answer that we got using the minus b formula. And in fact, it's the complete square form that actually allows us to derive the quadratic formula itself. So I think that this method is easier if you already have the function in completed square form.